So, good evening, everyone. Okay, so welcome everyone to the NPTEL course on post-harvest operations and processing of fruits, vegetables, spices, and plantation crop products. So, this is the course which is instructed by Professor H.N. Mishra sir, who is in the Department of Agriculture and Food Engineering, IIT Kharagpur. And I am Shikha Sharma. I am a research scholar in the Department of Chemical Engineering, IIT Guwahati, and I am the TA of this course for this July 2026 semester. And this lecture is a tutorial type of the lecture, and which will going to help you to solve your assignments for the respective week. So this is a live interaction session for week 2, and the assignment deadline for week 2 is 5th of August 2026. Topics that we will be discussing in today's session, it will include the module 2. Basically the topics will be post-harvest losses and preventive measures. Then post-harvest operations, handling and transportation, supply chain management and storage, quality assurance and control, QA and QC. This module 2 includes lecture 6 to lecture 10. So lecture 6 is about post-harvest losses, causes and preventive measures. And lecture 7 is about post-harvest operations. Lecture 8 is about handling and transportation. Lecture 9 is about supply chain management and storage. Lecture 10 is about quality assurance and control, QA and QC. So I hope you have all gone through this lecture, this module 2, week 2, which includes lecture 6 to 10 of Professor Mishra. So now what we can do is, based on the lectures, we can solve some concept-based questions, and also we will be solving some numericals in this session, which will be based on all these lectures. So if you have any doubt regarding module 2, which includes lecture 6 to 10, or module 1, which includes lecture 1 to 5, so you can ask in this class. Also, if you have doubt regarding today's any question, be it numerical or be it concept based question, so you can ask uh, when we will solve those questions. So you can ask at that moment itself. Also, you can ask at the end of this lecture. Okay, so let's start with today's first question then. Okay, so we will be discussing the basic concept first, so that we can start with our first question. So, as we discussed already, that we will be discussing about post-harvest losses. Initially, we'll discuss about post-harvest losses and what are its causes and preventive measures. So, basically, uh, the different post-harvest losses of the different fruits and vegetables. What are the factors which are affecting those post-harvest losses? So there are two major factors due to which the post-harvest losses are there, and there is so much of food waste, and there is so much of food waste and food losses are there. So these food losses and food waste can be reduced if we can understand all these factors which are affecting these post-harvest losses, and we can try to control these parameters so that the losses will be less. So the factors which are affecting the post-harvest losses, they can be divided into two, which is like one is a primary factors, another is a secondary factors, and it includes basically the different biological and microbial factors, which is the basically damage due to the insects, pests, animals, and different microorganisms like fungi or the bacteria. Then second is the chemical and biochemical factors. So these basically includes the undesirable reactions basically among the chemical compounds which are present in the food. So there can be browning and there can also be the acidity. Then third is mechanical factors. So mechanical factors includes basically the bruising or the abrasions or basically the puncturing and the crushing of the fruits or vegetables during the transportation or loading, unloading or during the storage time. And then physical factors are there, which includes like the environmental factors or in which storage environment, when we are storing, which kind of environment, or when we are transporting, which kind of environment we are providing to fruits or the vegetables. So it may include about like the temperature or the relative humidity and the air speed, etc. Then another factor is physiological, which includes sprouting, senescence, and the respiratory and the transpiratory, the changes which are due to respiration and the transpiration. And then the psychological factors are there, which includes human aversions or refusal due to the personal reasons or sometimes due to the religious reasons. Suppose some people are vegan, so they will not gonna eat milk products or they will not gonna eat egg or meat products. So because of their certain religious reasons, they will, or some people are allergic to some particular kind of proteins. Sometimes like some people are allergic to mushroom or peanuts, so they cannot eat that also. And that may lead to losses of that fruits or the vegetables or maybe or other food commodities also. So let's discuss first question. So first question is having one assertion: storing bananas and other climatic fruits at or below 12 degrees Celsius can lead to chilling injury. And the reason says that low temperature exposure causes excessive reactive oxygen species generation, leading to membrane damage and enzymatic browning. So we need to tell whether the assertion is true or not, reason is true or not, and if the reason is correctly explaining the assertion. So, as we discussed that there are different post-harvest losses factors, which are contributing. These are the different factors which are contributing to these post-harvest losses. In this, there are primary and secondary factors, right? So here we discussed that there are primary and secondary factors. Here we whatever factors we discussed like biological and microbial or the chemical and biochemical or the mechanical, physical, physiological or psychological. So these are all the primary factors we were discussing here. These are the primary factors which affects the post-harvest losses. Now this is the, here we are talking about the secondary factors. So secondary factors basically includes the biological factors like respiration rate, ethylene production, and then growth and development, and also the transpiration of the product, and also the physical damage and pathological breakdown, membrane permeability, surface area to volume. So all these parameters, these are the biological factors, and the environmental factors like the temperature, relative humidity, gases composition in the atmosphere, and then ethylene amount and light. All these factors, these are the environmental factors which will going to affect the post-harvest losses. So here we are discussing basically that we are storing the banana and other climatic fruit at temperature or at or below 12 degree Celsius, and we are talking about here temperature. So temperature is a factor in the environmental factor. which we are discussing here. So here, basically, if the temperature is like if the temperature is undesirable, so it may leads to several problems like freezing injury, chilling injury, and the heat injury. So if here banana basically it is storing at the environmental temperature of less than 12 degree. So reason is saying that when a low temperature storage is there, so ROS, which is the reactive oxygen species, will generate and it will lead to membrane damage and enzymatic browning, led to enzymatic browning. So let's see the answer. So answer is A here, which is that both A and R are true, but the reason is also the reason is the correct explanation of assertion. So here we are basically discussing about the low temperature storage, which is about the chilling injury we are talking about. That chilling, when we are storing these bananas at lower temperatures less than 12 degrees Celsius, then chilling injury is occurring. So what is chilling injury basically? Chilling injury is basically can be observed basically in fruits and vegetables like the peaches and the bananas and the mangoes and also in the zucchini or zucchini. When they are stored at low temperature for a period of time or for a long period of time or some period of time, when we are storing these fruits and vegetables at a low temperature of storage, then this chilling injury can occur. So the symptoms, it may include basically the pitting, browning, softening, and even in some cases there can be the decay of the product. So these negative effects will reduce customers basically desire to buy those fruits and vegetables, and it may lead to the large of economic losses to the farmers and the retailers both. So this chilling injury, because when we are storing the fruits and vegetable at very low temperature, like sometimes we say that we should store fruits and vegetable in the refrigerated or in low temperature storage so that their respiration and the transpiration rate or their senescence rate will decrease down. But then we should not decrease the temperature below an optimal level, because beyond that the chilling injury can occur, which may also lead to the different like pitting, browning, or softening of the food product or the fruits and the vegetables, which eventually leads to the losses of the economic losses to the farmers or to the customer, to the retailers also. So the chilling injury in climatic fruits like the bananas, it occurs when stored at or below 12 degrees Celsius. So in the subtropical fruits, uh, basically they will suffer from chilling injury at the temperature of around 5 to 8 degrees Celsius, while in the tropical fruits, they will suffer from the chilling injury when the temperature is lower than 12 degrees Celsius. So this so the different kind of fruits, they can have different kind of like different range of the temperature for tolerating the low like the uh, for tolerating their resisting the chilling injury. So in the subtropical it's lesser, and in the tropical it's around more, like it's around 12 degrees Celsius. Then why this, what is the mechanism behind the chilling injury? So there is a popular theory which is called membrane lipid phase transition. So what happens basically, uh, we say that in membrane of any cell, so there are these lipids. So these lipids are in the liquid crystalline form. So when there is a chilling stress is there, so what is going to happen? They will convert into solid gel form. And because they are converting into their phase is transitioning, so we call it membrane lipid phase transition. So when it is when it is converted, this lipid uh, membrane, it's converted from liquid crystalline to solid gel, then it may increase the cell membrane permeability, which will lead to the leakage of the electrolyte, and thereby the cell damage and the lysis is happening. And the another mechanism is that uh, after this solid gel is formed, so Ca2 plus systolic will going to increase, and because of that, the free fatty acids will be more, and then they will convert like these free fatty acids, they will convert into their peroxide forms, and due to because these fatty acids, they are converted into the peroxide form or oxidized form, so the cell is overall oxidized, and thereby the cell damage or the lysis is happening. And another mechanism is when the solid gel is converted, so it may lead to the disturbance of the functions of the membrane proteins as well. So the photosynthesis uh, is changing, and the rate of respiration is changing, and it decreases. And because of that, radical these reactive oxygen species ROS, they will overproduce, and which will going to lead to the peroxidation or oxidation of the membrane lipids, and overall the enzymes like the polyphenol oxidase, they will also act, and finally the cell oxidation is happening and the decay process is happening, and thereby the cell is damaged and the lysis of the cell is happening. So here, this is a table on the this side. On this right side, we have the table of chilling injury symptoms in different fruits. So we have like cucumber. So what are the symptoms in the cucumber? We can see there can be surface pitting, then there can be increase in the yellowing, and the disease susceptibility will be more, and then water soaking areas we can find on the flesh of the cucumber. So the threshold temperature is around 10 to 12 degree. Below this, the chilling injury can occur. In the eggplant or the brinjal, it is 8 to 12 degrees Celsius. So there can be like surface pitting or scalp can form, or also browning of the flesh and the seeds can occur. Then in the bell pepper, surface pitting, water soaked areas, and the seed browning can occur. And then okra, which is the uh, lady finger. So in this, the temperature is around 7 to 10, and in zucchini, 7 to 10, and in beta gourd, so 8 to 10 is the threshold temperature. And below this, if we go uh, for the storage, there can be different uh, like issues we can see in the fruits or the vegetables, like surface pitting, or maybe scald formation or browning, or water soaked areas can form. The second theory about the chilling injury is that at the low temperature, the hydrophobic bonds in the protein molecules, so they will gonna weak, while the hydrogen bond and the interaction between the hydrogen bond and electrostatic attraction, it will going to strengthen. So because of that, at the low temperature stresses, it will basically cause the change in the conformation of the proteins, which includes antioxidants and the enzymes, uh, antioxidant enzymes, so which will going to affect the activity of different enzymes, and it will lead to their continuous decline, and thus so therefore it will affect the regulation of many antioxidant enzymes on the accumulation of the reactive oxygen in the cells. So yeah, there was some interruption. Okay, let's begin from where we stopped. So we were discussing about the mechanisms of the chilling injury. Yeah, so we were discussing that chilling injury. In the chilling injury, there is a second mechanism which talks about that at the low temperature, the protein molecules basically, sorry, yeah, so the protein molecules, they will basically, these protein molecules, they will have this hydrophobic bonds. So those hydrophobic bonds in the protein molecules, they will going to weaken or they will break, and the hydrogen bonds and the electrostatic interactions, they will increase or strengthen. Because of that, the stress when the fruits or the vegetables, they are stored at the low temperature, so there is a change in the conformation of the protein. So protein conformation may get changed. So because of that, the enzymes, so the antioxidant enzymes, their activity will going to be hamper, or they will change the those activities of the enzymes. They are going not going to be same. Then because of that, uh, the regulation, what these antioxidant enzymes, what they are regulating, so they are their activity will going to decline. So because of that, there will be more accumulation of these reactive oxygen free radicals in the cells, and because of that, the metabolic imbalances, abnormal metabolic balances or metabolic imbalances can be observed in the cells. So because of that, the surface pitting or other degradative changes we can observe on the surface of the fruits or the vegetables. Third theory of this chilling injury behind, like it is explaining why this is happening. So the mechanism of chilling injury is explained by the third theory, which is the biological free radicals theory. So it's about free radicals. So biological free radicals, they have a strong destructive effects on biological macromolecules like the chloroplasts, protein, nucleic acids in the cell. So when the tissues of fruits and vegetables, they are subjected to low temperature, so what will happen? The ability of scavenging active oxygen-free radicals in the fruits and the vegetables, it is weakened. So thereby there is more accumulation of the excessive free radicals in the those cells of the fruits and vegetables, which will going to lead to the destruction of the biological macromolecules, in particular basically the double bonds of the unsaturated fatty acids in the membrane lipid. So in the cell membrane, the lipid layers are there. So in that, the unsaturated fatty acids or the double bond uh, fatty acids, they will be basically attacked by this free radical, and the peroxidation will going to or the oxidation of these cell membrane lipids, they will going to happen, and lipids, because of this lipid peroxidation, new free radicals will generate, and the free radicals, they are basically the main culprits which are going to accelerate the cell death, because it is promoting the lipid peroxidation of the cell membrane, thereby disrupting the integrity of the membranes. So here also we discussed about the same thing, that because of the different mechanism, the free radicals are formed, and they are going to uh, uh, damage the cell and the also the integrity of the cell membrane. So here we can see it is a pomegranate which is having this skin discoloration, and internal albedo, which is this white part, it is getting brown. Here we can see this is browning of the albedo, and the arils, which are this uh, uh, we have what we eat in the pomegranate, so they are the red part. So these are going to from red to brown, they are changing because of the chilling injury. After 120 days of the storage at 3.5 degrees Celsius and 95% relative humidity. So here also in the second example, we can see that in the mandarin fruit, mandarin is basically similar to oranges. So in mandarin fruits, when there is no chilling injury, it is looking like this. So it is 10% chilling injury, 11 to 50% chilling injury, and more than 50% chilling injury. So we can see here browning, so much of browning is there. And third case is the banana. So when banana is stored for 6 days at this is a 4 degrees Celsius and this is a 25 degrees Celsius. So we can see at the 4 degrees Celsius how much is the browning is there, which is because of the chilling injury. And if we talk about in with the like if we measure the browning, we can see a very high browning at 4 degrees Celsius compared to 25 degrees Celsius. And this is the hue angle, so which is basically telling the color, one of the parameter of the color. So it is telling that uh, initially to the after 6 days, at when we are storing the bananas at 25 degrees Celsius, then uh, there is not much change in the color. But when we talk about at 4 storage at 4 degrees Celsius, the color is largely impacted because of the chilling injury. So here from this uh, description, we can tell that the assertion, which is the storing the banana and the other climatic fruit at or below 12 degrees Celsius, it can obviously lead to chilling injury. And then low temperatures exposure, they will going to produce more of the reactive oxygen species, and which can lead to the damage of the membrane, and also the enzymatic browning can also occur. So A is true here. Then the next question is about the numerical problem, one of the numerical problem. So let me take the attendance. Yes, sir. Kindly join the session so that you can solve the questions here in the class and we can have a more interactive session. Okay, let's discuss the second question. Okay, so the rate constant for a reaction in the food is around 5 m per mole per second at 127 degrees Celsius. The activation energy is given as 400 kilojoule per mole. Calculate the rate constant at temperature 130 degrees Celsius, and R is given here as, which is the universal gas constant, is given as 8.314 joule per mole Kelvin. So as we discussed already that the post-harvest losses can be affected by different factors, the primary and the secondary factors. So here we are talking about we are changing the temperature of the environment, right? So environmental change temperature, it is going to play a very important role because in the deterioration process, and it will going to affect the rate constant or the rate of the reaction in any of the reaction. So if the temperature is increased, so here this is the environmental factor which we are talking about, temperature. So temperature, if we are increasing around 10 degrees Celsius, so above the optimal, so what will going to happen? The rate of the reaction or the reaction will going to also the deterioration will going to increase by 2 to 3 times or 2 to 3 folds increase. So temperature, basically, it is going to affect the rate of the reaction, like the respiration or the transpiration. Also, it affects, and it affects the growth of the pathogens or the spoilage causing bacteria or the fungal growth also. It will going to impact. So therefore, when we are increasing the temperature or when we are reducing the temperature, there is a change in the deteriorative reactions, they will going to change, and the rate constant will also going to change. So let's solve this question here. So here rate constant is given as 5 at temperature 127 degrees Celsius. So R1 is 5 and temperature T1 is 127. So if we convert into Kelvin, so we should add 273. So 273 plus 127 is equals to 400 Kelvin. And here R2 we need to find out at temperature when we are increasing the temperature to 130 degree. So 130 degree Celsius, if we are increasing like from 127 degree Celsius, initial temperature is 127 degree Celsius, which is 400 Kelvin. And at this particular instant, the rate constant is 5. So when we are increasing the temperature by 3 degrees Celsius, what will going to happen? The temperature is more, so more collisions will be there and higher will be the rate constant. And because of that, at 130 degrees Celsius, which is 130 plus 273 is equals to 403 Kelvin, we need to find the rate constant, and it will going to increase because as we discussed that when we are increasing the temperature, rate of the deteriorative reactions will going to enhance around 2 to 3 times. And then activation energy is given as 400 kilojoule per mole. So 400 into 1000 is equals to 4 then 50 joule per mole. So we are converting kilojoule into joule. So it is 400 into 1000 we should multiply, and then R, which is universal gas constant, R is equals to 8.314 joule per mole Kelvin. So here we need to apply Arrhenius equation because the temperature dependence of the rate constant, which is K, is basically expressed by the Arrhenius equation, which is K equals to, K is here, this R1 and R2 is K. So we can write K1 and K2 instead of R1 and R2 is equals to, which is a rate constant basically, is equals to A, which is frequency factor, into e to the power minus EA. So minus EA is activation energy divided by RT. Here capital R is universal gas constant, which is constant 8.314 joule per mole Kelvin, and temperature T is basically changing, which is 127 and 130 degree Celsius. Okay, so we know Arrhenius equation, K equals to AE to the power minus EA by RT. So we can take ln both sides. So it will be basically ln K equals to ln A plus, because this is in the multiply state, so it will come as plus. So plus ln e to the power minus Ea by RT. Then for the reaction which is happening at temperature 1, so we can uh, change, like, because the reaction is same, but it is just happening at different temperatures. So the rate constant will going to change. So ln K1 for reaction 1 equals to ln A, which is constant because the reaction is same, plus then ln and E, it will solve as like 1, or it will remove and the power will come here, which is power is minus Ea by RT. So minus Ea by RT 1. So 1 is denoting first temperature. Then for reaction happening at temperature 2, ln K2 equals to ln A plus bracket minus Ea by RT. RT here, T is denoting temperature at the second moment or second instant we are taking. Then we can subtract equation 1 from the equation 2. So we can write ln K1 minus ln K2 equals to, this will cancel out, ln A minus ln A will cancel 0, then equals to minus Ea by RT1, then minus Ea by RT2. So it will be solved as plus RT2. So it will come as minus minus plus, which is this Ea by RT2. So since this is in ln and it is in minus, so we can write it into divide form. So ln K1 by K2 equals to 10 minus Ea by R we are taking as common, then bracket 1 upon T1 minus 1 upon T2. So this equation we will get. Now we just need to put the values. So ln K1 value, which is R1 value, is given as here 5, right? So ln K1, which is 5, by ln K2 we need to find out, equals to Ea, which is the activation energy 400 kilojoule per mole. So we are converting into joule. So 400 into 1000 joule per mole divided by R, which is 8.314, bracket 1 upon T1. T1 is 127 degree or 400 Kelvin, minus 1 upon T2, which is T2 is basically 130 degree, which is 403. Now let's solve this equation. So ln 5 by K2 equals to minus 4, and then 0, 0, 0, 0, 0 divided by 8.314 bracket, then 403 minus 400 divided by 400 into 403. Then we can solve like this. So here it will be just 1000. So 1000 divided by 8.314, then bracket, this is 3 divided by 403. So ln 5 by K2 equals to minus 1000 by 8.314 multiply 3 divided by 403. So when we solve this part, we are gonna get minus 0.8954, and we can remove now ln. So it will be e to the power. So it will be 5 by, like when we remove ln, the 5 by K2 equals to e to the power minus 0.8954. So K2 will be, this K2 now will be equals to 5 upon e to the power minus 0.8954. So when we solve this, e to the power minus 0.8954, it will be 0.4084. So 5 divided by 0.4084 will be 12.24. So now the answer we can see it is around between 12 to 13. So C is correct answer here. Okay, let's discuss about next question. So a cold storage facility, it receives basically the shipment of tomatoes, bananas, then leafy greeny vegetables. So for the short-term preservation and distribution. The facility is operating at a temperature of around 5 degrees Celsius with 95% relative humidity and has a limited air exchange causing elevated CO2 and depleted O2 levels. After a few days, quality complaints are received like bananas are showing the black spots, then tomatoes have developed poor color and leafy greens appear slimy and spoiled. So which of the following best explains the cause of deterioration across the stored commodities? As we already know that here we are discussing about the cold storage facility. So we are discussing about the secondary factors of the post-harvest losses, like the environmental factors we are discussing here. Temperature is basically 5 degrees Celsius, relative humidity 95%, and the atmospheric conditions that CO2 is more and O2 is depleted. So we should tell now that if the deterioration is happening in the stored commodities, what could be the reason? Okay, let's discuss the solution part. So the combined effect of low temperature, high relative humidity and poor gas exchange is going to lead to the chilling injury, microbial growth and irregular ripening. So the environmental factors which are deteriorating the fruits and vegetables, it can be temperature, relative humidity, atmospheric gas composition, and then the light also can affect the shelf life of these fruits and vegetables. So temperature we already discussed in detail that, and also we discussed about the Arrhenius equation. So now let's discuss about the relative humidity. So relative humidity also has a direct effect on the rate of the growth of the microorganisms in association with the temperature. So the combination of relative humidity and temperature, it can basically elevate or it can reduce the deterioration. So the humidity level, it should be controlled so that the dehydration, like it should not be very low, that the dehydration or the water loss is there, and it should not be very high so that the molds or the microorganisms can grow and spoil the food products. So the temperature, basically combination of the temperature and relative humidity. If the temperature is high and the relative humidity is low, so deterioration will be very high. And temperature is high and the relative humidity is high, then deterioration is very high. And if the temperature is low and the relative humidity is low, deterioration is moderate, and the temperature is low and the relative humidity is high, then the deterioration is low level. So as we can see here, that because we are having the different temperature and the humidity or the moisture content, what microorganisms can grow. So here, if we are having low humidity, so microorganisms or low water activity or moisture content, water microorganisms will not able to grow. But as we increase the humidity, like here, maximum humidity is there. So because of that, the microorganism will grow more. So if we see here that at more than 90 degree relative humidity, most of the post-harvest diseases is occurring or it happens. And basically at around 8.8 to 1 water activity level, basically maximum decay is there, because here bacteria can grow, mainly bacteria can grow and spoil. And at the water activity level 0.7, so molds and the yeast, they can grow. So at higher water activity level, around 0.7 to 1, so maximum amount of the spoilage will be there. And if the water activity level is greater than like 90% or 0.9%, zero point 0.9 water activity or 90% relative humidity, so the maximum, like this is the area zone 3. So maximum, like the bacteria can grow, yeast can grow, molds can grow, and then different enzymatic reactions or enzymatic activities can happen in this area, in this zone 3. And then different hydrolytic reactions can occur, lipids can oxidize, non-enzymatic browning can also occur. So all kind of deteriorative activities can be there. So as we are reducing to like going from zone 3 to zone 2 to zone 1, so here if we see the deteriorative reactions are very low, even like here. So this is very low. This is the lipid oxidation. So lipid oxidation is all even low, and no enzymatic activity like this enzymatic activity, it is starting from zero point 0.3 water activity. So it is also not there. So or also the mold and yeast growth, they will also after zero point 0.7 they will be there. So at from zone 3 to zone 1 when we come, so the deterioration level will be low. When we talk about the atmospheric gas composition, so the gas composition basically it is referring O2, CO2 and ethylene. So when there is a high CO2 and low O2, so what is happening? Spoilage will be more. Anaerobic reaction or anaerobic respiration will be there, and irregular ripening will be there, and also the texture loss will be there. Because of the light also, like potatoes, when they are exposed to the light, there can be the greening of the tubers due to the formation of the chlorophyll and solanine, solanine, so which is going to toxic for the human health. And thereby because of the light also, there can be deteriorative reactions, and other factors like other chemical compounds or the pesticides or the growth regulators, they will basically, if applied to some of the commodities, so it will going to deteriorate with the color, flavor, texture, and nutrition value of the commodity. So, so here we can see the temperature basically is affecting, then relative humidity is affecting, the atmospheric gases composition is affecting, light, and then other chemicals also are affecting the basically the shelf life of the fruits and the vegetables. So basically here in the question, tomatoes and bananas, they are basically the climatic fruits, and they are sensitive to chilling injury at temperatures 12 degrees Celsius or lower. So when we are storing basically tomatoes and bananas, so it is basically chilling injury is happening because the temperature is less than 12 degrees Celsius. Then leafy vegetables or leafy greens, they are deteriorate more at RH greater than 90 degree, because it will going to encourage bacterial and fungal growth, as we saw here, that after 90% relative humidity, bacteria and the fungal growth will be more, or the more deteriorative reactions will be there. And high CO2 and low O2, it is going to basically cause the anaerobic respiration of flavors, irregular ripening, and we can see this is in the fruits like tomatoes. So all the environmental factors, they are going to affect the quality losses. So here low temperature, RH and high RH and poor gas exchange is leading to chilling injury, microbial growth, and irregular ripening. Okay, let's solve this question. That calculate the water activity for a mixture which is having 1 kg of water and 1200 gram KCl. So it is H2O in KCl in H2O. So by applying the Raoult's law, we should calculate the water activity level, and molecular weight of KCl and water is given as 74.55 gram per mole and 18 gram per mole. Okay, let's solve this question. So basically, Raoult's law is when a solvent's partial vapor pressure in the solution or in the mixture form is measuring, so it is equals to, like, suppose in one beaker I am having uh, like the water and KCl, KCl and water. So this is basically now a mixture. So when I want to measure uh, solvent, which is H2O. So when I want to measure the solvent's partial vapor pressure in this whole mixture, it will be equal to the, or identical to, the vapor pressure of the pure solvent multiplied by its mole fraction in the solution. So it will be partial vapor pressure of the solution is equals to its mole fraction, like this, H2O's mole fraction, and it's at the pure solvent's vapor pressure. So P solution is vapor pressure of the solution, X solvent is mole fraction of the solvent, and P naught solvent is vapor pressure of the pure solvent. So basically what is happening when there is a pure solvent? So it will have different vapor pressure, but when we are having this mixture, like the pure solvent plus some ion, like the KCl here, so it will have the different vapor pressure because the number of the particles is changed here. Okay, so let's solve this question now. So mass of the water is given 1 kg, which is 1000 gram. Mass of the KCl is given 200 grams. Number of the ions in KCl is 2, which is K plus, and HCl minus. Cl minus. Then molecular weight of the water is given 18 gram per mole and KCl is 74.55 gram per mole. And we need to calculate the water activity. So this is the pure water, 1 kg of the water. So the water molecule escape as vapors. Now water with KCl, so there is a presence of this non-volatile KCl, so it will reduce the escaping tendency of the water molecule from the surface. So according to the basically the Raoult's law, so we discussed already, Raoult's law is this: P solution equals to X, which is the mole fraction of the solvent, and multiply by the vapor pressure in the pure solvent form. So for dilute solutions, for a volatile solvent with a non-volatile solute, the water activity will be equals to the mole fraction of the water in the solution. So we need to calculate here water activity, which is going to equal to the mole fraction of the solvent. So mole fraction is basically here, if we see mole fraction, so mole fraction can be equals to P solution by P by P naught, right? So here mole fraction is equals to P by P naught, which is equals to water activity. So the water activity will be going to equal to the mole fraction. So mole fraction is equals to this, basically, that the weight of the water, which is given as 1000, divided by its molecular weight, which is 18. So 1000 divided by 18, which is equals to 55.56, divided by the mass of the water, which is 1000, divided by its molecular weight, which is divided by 18. So it will be 1000 divided by 18, 55.56 plus the ions. What are the numbers? What is the number of ions? So it is 2 in the KCl. So 2 into the mass of the KCl here, which is 200 divided by its molecular weight, which is 74.55. So 200 divided by 74.55 is 2.68. So here 55.56 divided by 55.56 plus 2, which is number of ions, into 2.26, 2.68. So when we solve this, 2.68 into 2 is 5.36. So 55.56 divided by 55.56 plus 5.36. It basically it is equals to this 55.56 plus 5.36 will be 60.92. So 55.56 divided by 60.92 will be 0.912. So here answer C is correct, around 0.912. Okay, now let's discuss about the preventive measures. These previously we discussed about what are the different factors which are contributing to the post-harvest losses. Now, when we try to minimize the post-harvest losses, what are the different preventive measures we can take? So we can put the fruits and vegetable into cold storage. We can go for waxing, irradiation, then edible coating, then controlled atmosphere storage, then modified atmosphere packaging and pre-packaging, and also the evaporative cool storage. So when we have the fruits and vegetable, and if its quality is decreasing or the pathogens are attacking, we can go for different treatments. Like we can go for 1-MCT treatment for inhibition of ethylene, and we can go for the edible coating. We can go for cold storage, controlled atmosphere, modified atmosphere, ultra low oxygen atmosphere, and we can treat with LED lights or different physical treatments, or essential oils also can be used to reduce the microorganism loads. So these are the different preventive measures we can do for reducing the post-harvest losses. Okay, so let's discuss this question now. So which of the following statements regarding preventive measures for reducing post-harvest losses in fruits and vegetables are correct? So cold storage and evaporative cool storage, it is going to help in reducing the respiration rate and delaying the senescence. Then waxing and edible coating forms a protective barrier that reduces the moisture loss and microbial invasion. And then controlled atmosphere or the modified atmosphere packaging, it is going to regulate gases composition and around the food product. And pre-packing and the irradiation, it increases the shelf life by increasing the metabolic activity. Okay, so the answer is 1, 2, and 3 statements are correct. So basically, waxing is the protective coating which is around the fruits and vegetables. So we see in the market waxed coated apples. So they will going to basically the wax around the apple, it will going to reduce in the moisture loss, and it will also reduce the rate of respiration. So thereby the shelf life is increased. In evaporative cool storage, what happened basically, this is evaporative cool storage. So here there will be the storage of water, and the water is basically sprinkled, or the water is filled in this area. So this is basically a two double-walled brick will be there. So between the space of the like there will be one wall like this, and then another like this. So here in this area, water will be filled, and inside this area, the fruits will be stored. So it is basically the best storage, best short-term storage of fruits and vegetable at the farm level. So it helps the farmers to get the better returns of their produce by slowing down the deterioration, and it helps also in reducing the shriveling of the horticulture crops, and it extends basically the storage life. Then pre-packing. In this, we can pack the fruits and the vegetables. So it controls the rate of the respiration and the transpiration, and it keeps the commodity in fresh condition, both at the ambient and low temperature, and it reduces the microbial load, and it benefits both the consumers and the producers because of its low cost and ready availability. Then cold storage. This is the cold storage facility. So it stores the fruits and vegetables for basically the long-term storage purposes. And the principle of maintaining a low temperature is because of slow down the reaction, and therefore it delays the ripening process. Then modified atmosphere packaging. It basically modifies the atmosphere composition inside the package by respiration. So here in this package, like this, so the, uh, basically what will going to happen, the air, which is the level of O2 and CO2, it can be altered. So atmosphere can be modified. It will extend the shelf life of bananas, carrots, capsicum, green chilies, and tomatoes. So papaya can be stored up to around 4 weeks when it is stored at 10 to 12 degrees Celsius under modified atmosphere conditions, while using the low temperature. We can store the Cavendish banana, capsicum, green chili, and tomatoes to around 42, 21, 28, and 30 days respectively. So then this is the controlled storage, atmosphere storage. Here what happened? The principle of maintaining an artificial atmosphere which is having high concentration of CO2 and low concentration of O2, then normal atmosphere is to basically it is reducing the respiration and the aging process, and it also combined with the low temperature. So it will going to basically use low temperature plus high CO2 level and low O2 level, so that the overall like the fruits and the vegetables can be stored for long term, and the aging or the ripening can be delayed because the respiration rate can be slowed down. Then irradiation, it is a novel technology which is reducing the post-harvest losses and extend the storage life. Like this is the irradiated strawberries, and there is this sign or is label on the label if any fruits and vegetables is irradiated. So the gamma rays basically at optimal doses delays ripening, and it minimizes insect infestations, and it retards microbial spoilage, and it control basically the sprouting and rotting of the onion, garlic, and potato during the storage, and it is used as disinfectant or disinfection treatment, and it controls the fruit flies on citrus, mango seeds, uh, weevil, and also the papaya fruit flies. And this is the edible coated tomatoes. So this is the control one, and this is the edible coated one. So continuous matrix which will readable coating is basically a continuous matrix which will prepared from the edible materials like the proteins, polysaccharides, lipids, or the plant extracts, or essential oils from all these combination. We make one coating solution and we coat the fruits and vegetables so that it will going to control the migration of gases, moisture, oil, fat, and solutes, as well as flavoring compounds, and it improves structural integrity and mechanical handling so that the overall quality can be maintained and microbial growth can be stopped. So here we can see that the cold storage and the evaporative cool storage, it is going to reduce the respiration rate and delay the senescence, whereas the waxing and edible coating, it is basically forming a protective barrier around the food product so that the moisture loss will be less and microbial invasion will be less. And controlled and modified atmosphere packaging, they are basically going to regulate with the gas composition. So these are three correct. And pre-packaging and irradiation, they increase the shelf life, obviously. By increasing the metabolic activity, no, it decreases the metabolic activity. Okay, let's discuss this question. Match the fruits and the vegetables which are given in column 1, like apple, then grapes, cabbage, and mango. And in column 2, we have the chemicals used to control the post-harvest spoilage or improve the quality. So these are different chemicals like SO2 fumigation, hot water, benomyl, sodium phenyl phenate, and thiabendazole. So this is basically sulfur. So when SO2 fumigation is there, this molecule plays its role. So these are the different chemicals and their structures. So this is basically the benomyl. So this is sodium phenyl phenate and this is thiabendazole. So this is the different chemical structures of these chemicals which are used for the controlling the post-harvest spoilage. We need to match in from column 1 to column 2, which are the fruits and vegetables on which different chemicals are being applied. So answer is first, which is in apple, there is this sodium phenyl phenate is applied. In grapes, SO2 fumigation. In cabbage, thiabendazole or benomyl, and in mango, hot water or benomyl. So apple is basically treated with this. Carrots and cabbage, they are basically treated with thiabendazole and benomyl, and grapes is treated with SO2 fumigation. Mango is treated with hot water and benomyl. So this is a table which is given in the lecture discussed by Professor Mishra also, that these are the different chemicals, these are the different fruits list, and these are the different chemicals which are being applied to increase their shelf life. And here are the concentration of some of the chemicals also given. These are the different chemicals, commodities, and their concentration. So here answer first A is correct. Okay, let's discuss about blanching. So which of the following statement is correct about blanching? So blanching is used for enzyme inactivation in fruits and vegetables. Blanching is a severe thermal process. Blanching uses only hot air for heating the product, and blanching is typically performed at temperature below 50 degrees Celsius. So which statement is correct here? So this blanching, it basically comes in the processing operations. So when we discuss different processing operation of fruits and vegetables, like it includes like primary, secondary, and tertiary processing. So in primary operation, we have sorting and grading, washing, then ripening, and then blanching and size reduction. So this blanching comes in the primary operations of fruits and vegetables. Okay, so answer A is correct, that blanching is basically used for enzyme inactivation in fruits and vegetables. So basically, this blanching is a mild heat treatment that is going to inactivate the enzymes, and it destroys the microorganisms that might contaminate raw vegetables and fruits during production, harvesting, and transportation. So it involves basically heating the fruits and vegetables to a temperature around 88 to 99 degrees Celsius, which may be achieved using air, water, and steam, and for a time period of around 1 to less than 10 minutes. So basically, this blanching is a mild heat treatment, and it is going to inactivate the enzymes like the polyphenol oxidase, pectin methylesterase, and polygalacturonase. So these all enzymes, like the PPO, it is going to cause the browning of flavor, and it will going to basically in the fruits and in vegetables, it oxidizes the phenolic compounds like the catechin, gallic acid, chlorogenic acid, and caffeic acids. So here, that blanching is basically used for inactivation of the enzymes in the fruits and vegetables. And now let's discuss about the handling of fruits and vegetables. So it can be, these fruits and vegetables can be handled at different stages, like at the harvest in the field, then loading and unloading, transportation, and then wholesale market, and at retail market, and at consumer end. And this fruits and vegetables, they can be basically transported, can be using road, rail, marine, and air. And, and because the issues in the transportation, like the poor temperature management or the lack of appropriate transport system, or the lack of refrigerated transport system, or loading and unloading practices, and the poor infrastructure, the different problems can occur, or the different post-harvest problems can occur in the fruits and vegetables. So these can be properly maintained. So let's discuss this question now. So there is this refrigerated transport company. So it is troubleshooting a mechanical failure in one of its diesel-driven vapor compression units. So the unit is not cooling despite the fuel engine working properly. So the technicians suspect that the main component in the vapor compression cycle may be malfunctioning. So which can be of this component is most likely causing the insufficient cooling by failing to absorb thermal energy from the environment? Is it compressor, condenser, evaporator, or expansion device? So this is basically the transport in which fruit and vegetable is being transported. So in this, this is a basically refrigerated transport system. So in the refrigerated transport system, here basically it is having this here at here it is having LNG tank, and second is a wall box here, and then here is basically all the cold energy recovery heat exchanger system, and here is the basically installed fans so that there is a proper homogeneous cooling of the of this container, and then here is the superheater, and here is the engine, and this whole body is basically or is a refrigerated vehicle body. So here, when we are transporting any fruits and vegetables, we should transport them in proper refrigerated transport system, and for that we need basically a proper heat exchanger kind of system, and it will have this compressor, condenser, evaporator, and expansion devices. So we need to tell that which one we can basically, which of these devices are basically is failing when there is not proper cooling of this unit. Okay, let's discuss the solution. That evaporator is not working well here. So basically, this is a vapor compression transport refrigeration unit, which is driven by a diesel engine. So here, basically, yeah. So this is the evaporator, and this is the compressor. This is the condenser, and this is the expansion valve. But here, basically, all this coolant is basically the expansion device, which is flowing in this system. So basically, the temperature control system, it is having most widely used method for basically the temperature control in the mechanical refrigeration, which operates on vapor compression refrigeration cycle, which is VCRS, and it has the following components like evaporator, which is allow for the evaporation of the refrigerant by absorbing the thermal energy from the environment to be cooled. So it will produce cooling effect because it will take energy. So here, like here, here, from here, it will take all the, absorb all the thermal energy for cooling. So it is a, here it will be the, basically this evaporator system. So it will take and evaporate basically the refrigerant by absorbing the thermal energy so that the cooling effect can be produced. If this component is not functioning correctly, so the refrigerant won't evaporate properly and it will going to lead to the poor cooling performance. Second is the compressor. So the compressor is basically compresses the refrigerant from the minimum pressure of the cycle to the maximum pressure. The minimum pressure is from the evaporator to condenser. So this is the evaporator and this is the condenser. So from evaporator, the refrigerant will absorb the energy and it will convert into the gaseous form, and from the liquid to gaseous form, and the compressor will going to compress that gases and or the fluid, and it will send into the condenser. So basically, compressor compresses the refrigerant from the minimum pressure of the cycle, which is from the evaporator, to the maximum pressure, which is condenser, by absorbing the mechanical energy from an external source. Then next is the condenser. Condenser is going to condense the refrigerant by rejecting the thermal energy to the external environment. So from here, the thermal energy will be sent to the environment and the refrigerant is now cool again. So the compressor and the condenser, it affects the pressure and heat rejection, but not directly responsible for absorbing the ambient heat. Then last is the expansion device. So it allows pressure drop from the condenser level to the evaporation level, but not create the cooling effect. So it is basically this expansion valve is basically going to reduce the pressure. So here, only the evaporator is the one which is going to absorb the thermal energy from the system so that the cooling can happen. So next is that when we are transporting the fruits and vegetables using different routes, so here we are transporting using marine transport. So marine transport is preferred for shipping fruits and vegetables with long shelf life. Reason is that the marine transport involves slower transit times, which are suitable for produce that is not going to spoil quickly. We need to tell here about the assertion and the reason. So here both the assertion and the reason are true, and assertion is basically the correct explanation of the reason is the correct explanation of the assertion. So basically marine transport is slow, but it is cost effective and it is ideal for commodities which are having the longer shelf life. So the reason basically accurately explains why such produce is suitable for this mode, and it can withstand the longer transit time without the quality loss. So basically the different transport systems. So in the road, basically transport system, shorter distances are usually covered. So the intercontinental shipments and the products which are having this low shelf life, and it takes around moderate cost, and it uses basically the refrigerated vans or the containers like this. Basically, this is the open container, but usually because it is going for a short distance, but usually the refrigerated kind of vans are there. In the rail transport, basically medium shelf life products are sent in the same continent, intercontinental, and it is moderate to low cost, and it uses basically the intermodal containers or the refrigerated uh, semi-trailers, or they can have this basically refrigerated rail cars like this. So they can send to some longer distances compared to the road transportation. And the commodities which is having which is not very exotic. They are the normal like the dairy products or like that, or the normal fruits and vegetables. So they can be transported to rail using rail transportation. Then marine transportation is used for basically intercontinental. So when we are trying to send some fruits and vegetables for the export, so we can use marine transport, and those fruits and vegetables should have higher shelf life, and it is the most economical way to send them using the refrigerated ships or the refrigerated containers. And air transport is basically also used for sending or for sending export, basically sending in another country. So it is basically used for sending very short shelf life products, and which are even exotic, or we can sell them at higher price. And then basically the journal cargoes and some specified refrigerated bodies or the containers can be used to transport using the air mode. And if we talk about the case study for banana, if we want to send banana in the international market, we can use the refrigerated vessels, or we can use the refrigerated shipping containers with ethylene scrubbers and at a temperature around 13 to 14, because less than 12 they can go under chilling engine. But when we want to send bananas in the domestic market, so we need to have refrigerated trucks or the lorries for short distances, and railway wagons for large volumes and medium distances, so that the mechanical stress during the road transportation can be reduced. So basically marine transport is used for shipping fruits and vegetables which are having a longer shelf life, and the marine transport basically involves slower transit times, and it is suitable for products which are not going to spoil quickly. So here A is correct, that the assertion and reason both are correct, and reason is correctly explaining the assertion. Okay, so let's discuss about hazards. So in column 1, there are different hazards, and in column 2, there are respective sources or like the related uh, toxins or related chemical compounds are there. So in column 1, it is given that hazards inherent to foods, then hazards associated with environmental contaminations, hazards arising from microbiological activities, and the hazards emerging from food processing. And in column 2, there are 4 options like allergens, mycotoxins, radionuclides, and chloropropanols. So we need to match column 1 with respect to column 2. The answer here is D, that hazards inherent to foods are basically allergens, and hazards associated with the environmental conditions, they are basically the radionuclides, and the hazards which are due to the microbial or microbiological activity, which is the mycotoxins, and the hazards emerging from food processing is basically the chloropropanols. So basically, we know that there are 3 hazards, like the hazards can be classified into 3 categories, like the physical, chemical, and the biological. So the physicals are the materials which are not normally found in the food, but like it can be put, like it is put into the food products, like the stones can be found, stem, and then seeds, hair, bone fragments, feathers, jewelry, nails, then balls, then basically nuts, bolts, and then nails, and then jute strings, then buttons, cigarettes, matchsticks. So these are all the physical hazards. Then the chemical hazards are basically intentionally or unintentionally added, and then unintentionally added, or they can be like the pesticides residue in the food product, then the veterinary residues, adulterants, and adulterants are the intentionally added. So cleaning chemicals, they can come unintentionally in the food product. Then excess of permissible food additives and non-permissible food additives can be added. Then it can be come into the category of chemical hazards. Then biological hazards is the living organisms like the microbial organisms can be added into the food product. So it can be visible like the worms, cockroaches, caterpillars, weevils, and flies. But it can also be invisible like bacteria, yeast, protozoas, molds, viruses, like that. So the food safety hazards encompasses all risks, both the chronic and acute, that could render food harmful to the consumer's health. So first is inherent hazards in the food includes basically the naturally occurring toxins or the allergens, and the food ingredients that some individuals cannot tolerate, basically the allergic food components. Then environmental contaminants are the hazards, which involves persistent organic pollutants, heavy metals, radionuclides, and similar elements. And then microbial hazards includes virus, bacteria, bacterial toxins, biogenic amines, and mycotoxins. And uh, the hazards which can be incorporated while food is being processed at the processing stage. So it includes the formation of the compounds like acrylamide, which is formed when the starchy food is fried, baked, roasted, or browned, and chloropropanols may form when vegetable oils, baked goods, and the infant formulas can be processed. During the processing, it can produce. So here, in the food, allergens can be found. Then from the environment, radionuclides for the heavy metals can be incorporated. Then microbial activity, like due to the microorganisms like mycotoxins, can be produced, and also from the food processing, chloropropanol can be added into the food product. Now, let's discuss about the primary reason. The primary reason healthy and the bruised apples can be differentiated using hyperspectral imaging before visible symptom appears is because, so basically now we are discussing then if any hazard is come to the food product, then how we can differentiate or how we can find out uh, which technique we can use. So here we are using, basically there are different techniques like X-ray, uh, then micro CT scans and other techniques. Then here we are basically discussing the hyperspectral imaging. So the primary reason to identify or to separate healthy from the bruised apple, healthy apple and the bruised apple, how we can differentiate visually, like before we can get the visual symptoms, how we can separate them as healthy and bruised using the hyperspectral imaging. So options are bruised tissues have a different shape. Then cellular damage changes the light absorption and scattering characteristics, altering the spectral signature. Then bruised feuds emit the ultraviolet radiation, and bruising basically change only the fuse external color. So here answer B is correct, that the cellular damage, if the fruit is not well, it's damaged internally, but outside we cannot see if it's damaged. So inside, what is going to happen? The cellular damages, they will going to change the light absorption and scattering characteristics. So the spectral signature will going to alter from the fresh one, and we can understand, okay, this fruit is basically not healthy and it is bruised. So the basic principle of hyperspectral imaging is basically is that the food basically yeah. So we were discussing about the hyperstructural imaging here. Yeah, so we were discussing about hyperstructural imaging. So the basic principle of hyperstructural imaging, sorry, is that the food basically reflects, scatters and absorbs, and it produces the electromagnetic energy in a different form at a particular wavelength. So when this is a fresh fruit, so when the electromagnetic radiation will come, healthy cells will act differently and the bruised cell will act differently. So it will basically, there can be difference in the absorption and the scattering phenomena of this, and basically the structural image can change, and the from the healthy to the bruised one. So the reflectance is plotted against the wavelength. So here at different wavelength, the reflectance is plotted, and the curve is referred to as the spectral signature of the constituents. So some curve will be there here, and the bruised and the healthy ones curve is different, gonna different. So it helps in determining the freshness, total soluble solid, Titrable acidity of mangoes in a spectral range of around 450 to 998 nanometers. So it can use basically UV or visible, and also sometimes IR also a reason to image or to get these wavelengths can be used to get the spectral image of the any food product. So the spectral image is basically commonly referred to as a hypercube, basically because it is going to store the information or the spectral information at each spatial pixel, forming two spatial dimensions and one spectral dimension. So it will gonna form like a cube, like we see here. So this is a hypercube. So the information is going to store in the form of the hypercube, which is basically the two spatial dimensions and one spectral dimension will be there. So the information of uh, any food product is going to be stored in the hyperspectral image in the form of the hypercubes, and it has the light source, then it has wavelength dispersion systems and the detectors. Like here it is given that one stage is there, over that sample will be put, and the visible NIR source, this is the radiation source or the light source will be there. This is the focusing lens is there, so it is going to focus on this particular view, and because of this so here in this particular region scanning will going to happen, and the data will be taken using the lenses, and the spectrograph will be formed and processed using the computer. So the information here will be in the form of the hypercube form. This data will be further like pre-treated, and it can be sent for supervised methods and unsupervised methods, like all the different regressions can be formed, and the models can be formed based on the whatever data we get from the hyperspectral images. So here the main principle is that absorption of the light and scattering of the light will be different in the bruised and the healthy apples. So we can differentiate based on the hyperspectral imaging even before the spoilage can be visible to our eyes. So these are some examples of the hyperspectral imaging basically. So this is basically the different apple like Bourbon, Royal Gala, Granny Smith, thin golden apple, and then non-thin golden apple. So these the slices of them are basically taken, and the total sugar content is being find out in different. The distribution of total sugar content is find out in different varieties of the apple using the hyperspectral imaging. So when redness is more, then means more amount of total sugar content. So this is more red. So this is more sugar is there in this. In this also more sugar, and more is the like this is the more blue. So it is less sugar is there. So initially the sugar is very less, and total sugar content, and then it will increase with the it is increasing in some of the slices like this. So we can find out how much is the sugar content. It can be based on the maturity, or when we are harvesting at different maturity. So the sugar content in different varieties or in the same variety can change. Then this is the hyperspectral imaging of the soluble and insoluble fiber distributions in the fresh cut celeries. when it is stored from 0 day to 21 days and 28 days of storage is there. So how much is the fiber content? Here is the insoluble fiber content, and it is B is the soluble fiber content in the cut celery for these many storage for these many days. Okay, next is basically this is the fresh cut potatoes and their starch distribution. So more red is there, that means more starch is there. So this is the basically starch distribution in the different slices of the potatoes. So here in one it is 11.8 gram per kg. Then in B it is 13.5, in C 19, and in D more red is there. That means 21.6 gram per kg starch is there. So this is the example of real life demonstration of hyperspectral imaging. Then let's discuss about the different sensors and in basically intelligent system or the smart food packaging. The sensors are basically used. So the sensors basically they can be of different sensors like spoilage, ripeness, time temperatures. These sensors can be sensed using the some basically some packaging system. So these sensors will be there. So it basically these sensors from these sensor inputs, these chips or different sensor chips or different electrodes will be there. They will basically going to produce some sensor signals, and finally those sensor signals will be converted into these are the sensors. Like first what is happening, suppose this is a packaging, in this some fruit is there, so some spoilage, ripeness or some sensor input will come from these fruits and vegetables. So these will be basically first converted into some electrical, electrochemical and chemical signals, and that is basically converted into some electrical signal kind of things. Basically maybe signal uh, production will be there, and then that signal will be finally processed and it will be finally sent as an output, like the color change will be there or the fading or the voltage change will be there. So these sensors can be basically the direct one and the indirect one. So the direct signals, they are basically the spoilage, ripeness, leak, microbial and ethylene gas, and indirect sensors are basically humidity and time temperature sensors. So these sensors, they are basically going to help in the monitoring of the freshness of fruits and vegetables. So the fruits freshness sensors or the indicators, they have been developed based on the senses of aldehyde, volatile organic compounds, ethanol, hydrogen sulfide, pH and CO2 levels. So the sensors will going to sense these. So the sensors or the indicators are integrated into the food packaging system as a visible indicator, label or tag that will going to undergo color change according to the changes in the freshness marker and or the analyte. So let's discuss about one question about sensors. So which of the following statement about freshness detection sensor in fruits and vegetables are correct? So the ripeness sensors work by detecting the aroma compounds released during the fruit's maturation process. Second is pH sensors are used to detect spoilage by monitoring changes in the headspace of the packaged produce. And third is the humidity sensors based on the capacitance change can detect variation in moisture and are indirect indicators of spoilage. And fourth is the spoilage sensors. They respond to color changes in fruit peeling to detect microbial decay. Okay, so here option 1, 2, and 3 are correct. So here we are talking basically about the direct sensors. So here the ripeness sensor, basically it works by detecting the aroma compounds released by the fruit maturation process, and pH sensors used to detect spoilage by monitoring changes in the headspace of the packaged product, and humidity sensors are the one based on the capacitance change. And this is basically humidity sensor is the indirect, basically can detect uh, variations in the moisture and are the indirect indicators of the spoilage. So it's 1, 2, and 3 are correct here. Fourth is incorrect, that the spoilage sensor respond to color change in the fruit peel to detect microbial decay. So these ripeness sensor and the pH sensors, they are basically the direct sensors, and they are basically direct sensors, and they detect basically a particular analyte directly from the fruit as an indicator for food freshness. And direct fruit freshness sensors, it can be spoilage sensors, ripeness, leak, microbial, pathogen, ethylene, and senescence indicators. So first is the spoilage sensor. So the spoilage can be basically detected using the chemical sensors like the pH sensors. So this pH sensor comes under basically the spoilage sensor. They are measuring from the pH of the food product. The pH of enclosed fruit package changes within the headspace, so which can be basically measured by the pH sensor. Like the formaldehyde was detected by exploiting the chemical reaction between formaldehyde and primary amines. And second is the ripeness sensors. So this is the ripeness sensor. So react with aroma and volatile compounds emitted by the ripening of the fruits like pears, kiwi fruits, melons, mango, and avocado. And different stages of fruit ripeness can be basically studied using electric nose. So this is the guava in the packing. So this is the color changing based on its ripeness. Then the colorimeter senses, so it utilizes basically the pH indicators based on methyl red to detect aldehyde emission as a marker of apple ripeness. So this is the setup here. These are the sensors which are put on the apple. So there are the color changes in the sensor labels after the exposure to apple flavors. So basically the color is changing in this case when the app on the apple when the storage days are increasing, or ripeness is more or the spoilage is more. Next is the indirect sensor. So they are humidity, temperature, time sensors. So indirect freshness sensors, they are based on indirect or reaction based detection of fruits degradation due to certain freshness parameters such as temperature and or time. Like some examples are humidity indicators, temperature indicators, time temperature indicators, and RFID based indicators. So these humidity sensors, they are basically the capacitive humidity sensors is basically a type of humidity sensor. So the hygrometers that utilize changes in the capacitance to detect the relative humidity level. So like this is the capacitive plate and this is a dielectric, and basically it will detect based on the capacitance change in the value of the capacitance or the voltage. So here there is nothing when water is incorporated here inside this, and then the basically the uh, change in the permittivity of the dielectric is there because of the water vapor. So when there is like fresh fluid and when there is a um, spoiled fluid, so there will be some changes in the water vapor in the from the atmosphere. So the formula will apply here is C equals to, which is capacitance is equals to dielectric constant of the food material, which will going to change for healthy and bruised fruit materials or spoiled fruit materials. Then E naught, which is permittivity, and then A is the area of this capacitance plate, and D is the distance between, divide by distance, which is the distance between these two plates. So it can be, this capacitance can be further converted into the voltage V equals to Q by C. Q is the how much is the charge deposited here, divided by the capacitance which we found from this formula. So this based on this, humidity sensors work. Then time temperature indicators are there, which have, they are there. So chemical and physical mechanisms are based on the basically the chemical reactions or any physical change. So due to changes in their time or temperature. So these are the different sensors. So this is a fresh one used. So this is basically fresh check and should not be used. So this is a, these are the time temperature sensors, examples of these sensors. This is time trip. This is basically monitor mark. And this is the checkpoint. So these are different time temperature sensors. So here in this question, we saw that the ripeness sensors, they are basically working by detecting the aroma compounds by the fruit's maturation process. So these are the ripeness compounds, aromas of the volatile compounds, they will sense this ripeness sensors. pH sensors, they are used to detect the spoilage by monitoring changes in the headspace of package produced. So the pH sensors, basically they are going to analyze the change in the headspace and going to understand the deterioration of a food product. Then humidity sensors, they are basically based on the capacitance change and detect based on the moisture variation, and they are the indirect sensors. So obviously they are indirect sensors, and based on the moisture level, they will understand the capacitance will gonna change, and finally the humidity, different humidity of the food product can be understood. Then spoilage sensors responds to color change in the fruit field to detect microbial decay, which is wrong. That spoilage sensor basically is working based on the pH sensing, whereas colorimeter sensors, they basically analyze the color. They are basically also utilizing the pH indicators uh, to understand if there is any change in the methyl red to detect the aldehyde emissions. So they are taking aldehyde emissions as a marker. So fourth one is wrong, rest are fine. Okay, now discuss about RFIDs. So RFID based system enable real-time traceability of perishable goods during storage and transport. And reason is that RFID tags require a reader, antenna, scanner to operate and transmit signal through the radio waves. So this is basically RFID chip. So answer is that both assertion and reason are true, but reason is not the correct explanation of assertion. So basically, RFID technology it is used to track and identify the food product quality during the storage and transportation in the containers, and these systems they use basically RFID tags, which is with an antenna, RFID sensors, and radio waves to communicate data to the networks. And these active tags they allow for the real time traceability as they can constantly send out the information. So freshness sensors are being employed commercially with these RFID tags to monitor relative humidity, temperature, light exposure, pressure, and pH of the foods. However, the reason basically it is explaining how RFID works, but it is not explaining why it enables real-time traceability. So the traceability is basically due to the functionality of active tags constantly sending updates, not just the presence of the hardware. Thus, the reason does not directly explain the assertion. So this is basically a food traceability using the smartphone and near field communication. So tracking and tracing across the food supply chain is happening. So this is basically the operator which is going to upload some information in the uh, RFID tagged product, and then another uh, operator at the processing level will going to upload some information. Another operator at distribution chain level, they will going to put some information, and then consumer also will going to check the information. This is the output. So at different level, like the primary processing or the raw material collection, and then at the different processing levels and at the distribution levels, the information will be feed into these apps or using these apps, and these all will be connected at some database or at some cloud storage, which will going to be basically can be accessed by company or the consumers using the app about that from that RFID tag that okay, this product is made in this condition or processed in this condition, then it is distributed using this channel. So usually what is happening that the operator read tag of the object with the device or the smartphone, then tag contains basically a link to a remote database of the company. History of the object is displayed to operator. Operator updates information on the remote database, adding information on GPS localization, code of the operator, and timestamp. If one or more objects are generated from the processed object, additional records in database are added and tags are generated containing a link to corresponding new record of the database, and the new record stores the link to the father object. So this is a meat supply chain. So this is at the farmer feeding level, then breeding, slaughter, distribution, and storage, and then finally to consumers. So in all this, the tracking and tracing across the supply chain can be maintained, maintained using this RFID tags. Like in a pig meat supply chain. So at the slaughterhouse, in the some lot of the pigs, RFID is there, and then at the slaughterhouse, the information is being like uploaded, and then the cutting app, then transformation app, and the packaging app, the information is uploaded and it is saved to the cloud database, and finally the consumers, after scanning the tag, can access the information and like in which condition or which lot it is being made. So this pig, it is having tag like it is having the records or the tables and relations of the database for slaughtering and food processing for pig meat. In the light blue are indicated the fields which are operated by the operator during the process. In green, the fixed data are there. So this green are the fixed data, and this is the information which will be uploaded by the operator. So the tag will be there and it will be scanned, RFID tag will be scanned, and the lot number, ID number can be filled. These different processing conditions, if it's refrigerated, not refrigerated, when it is cut, when it is cooked, when it is packed, all these information will be put. Like this is a real life example of using an RFID tag. The topics we discussed today is mostly like the post-harvest losses, the causes and the preventive measures, and then factors which are affecting the deterioration of fruits and vegetables, and then the post-harvest physiology of fruits and vegetables, and preventive measures for minimizing the post-harvest losses. And then we discussed about the different primary, secondary, and tertiary process operations for post-harvest operations. And then handling and transportation, we discussed like the handling of fruits and vegetables at different stages. Then the transportation and the refrigerated vehicles or the temperature control systems we discussed. And then we discussed about the supply chain of the food of this food uh, fruits and vegetables. And then we discussed about the quality control and quality assurance, where we discussed about its safety aspects and like the safety and the hazards, and how we can continuously measure the and monitor the detection or detect the spoilage, and then what are the different sensors. And in the next class, we'll be going to discuss about the basics of the processing and preservation, processing by removal of water, by addition of heat, and by removal of heat, then irradiation of fruits, vegetables, and spices. So this class, uh, basically after this lecture, I will be uploading basically the recorded video for week 2 on my YouTube channel, and the link is provided here. You can visit this link to watch recorded lectures of every week, and this PPT will going to be uploaded in this Google Drive form in this Google Drive link, and you can ask any doubt in the Q&A discussion group if you have any doubt. Thank you so much for joining the today's session. Please join the next session Sunday 4 to 6, and thank you so much for joining. Now I'm stopping the recording of the session. Please try to join the class on the live interaction session, and the recordings are just for the people who are busy somewhere and not able to access on time, so they can just watch the recorded lectures. Okay, so thank you everyone.